Welcome students, welcome to the Industrial Fluid Power session. Here today we are going to see about the introduction to pneumatic systems. So in this introduction to pneumatic systems, we are going to see about the application of pneumatic system, general layout of pneumatic system, merits and limitations of pneumatic systems. So in introduction about pneumatic technology. This pneumatic technology deals with the study of behavior and applications of compressed air in our daily life in general and manufacturing automation in particular. Pneumatic system use air as the medium, which is abundantly available and can be exhausted into the atmosphere after completion of the assigned task. So what is the difference between hydraulic and pneumatic system? In hydraulic system, it employs the pressurized liquid as a fluid. In pneumatic system, it employs the compressed gas, usually air as a fluid. In hydraulic system, an hydraulic system operates at pressure up to 700 bar. But in pneumatic system, a pneumatic system usually operates at 5 to 10 bar. Generally designed as closed system, which is a hydraulic system. But pneumatic system, it is designed as an open system because the return air will not come back to the tank. The return air will automatically exhaust to the atmosphere since it is a air. So there is no wastage. In hydraulic system, the system slows down when leakage occurs because it uses fluid, oil or water as a fluid. But in pneumatic system, leakage does not affect the system much. In hydraulic system, valve operations are difficult. In pneumatic system, valve operations are very easy. Hydraulic system, it is heavier in weight, but pneumatic system, it is lighter in weight. Hydraulic system, pumps are used to provide pressurized liquid. Here we are using the pump to pressurize or to pump the fluid from the tank to the system. But here in pneumatic system, compressors are used to provide compressed gases. In hydraulic system, the system is unsafe to fire hazard because here we are using oils, so it may provide fire hazards. But in pneumatic system, the system is free from fire hazards. Automatic lubrication is provided in hydraulic system, but in pneumatic system, special arrangements for lubrications are needed. Then what are the applications of pneumatic system? This pneumatic system is used as a pneumatic tools for drilling machines, nut runner, screwdriver, and packing machines, material handling like clamps, conveyor, robotic arm, in automobile air brake, air suspension, etc. In same time machine tools, pneumatic press, clamps, visors, etc. Medical and dental equipment, dental chair, operating table, dental drill. This is the general layout of pneumatic system. Here the air from the atmosphere, it goes to the air dryer and through compressor. This is simple. This symbol is a compressor, the air tank, and which motor is used to compress the air and goes to the air dryer and goes to the air filter, receiver tank, and then goes to the filter, regulator, lubricator, and to the direction control valve, then to the flow control valve, then to the actuator. Then return from it directly goes to the atmosphere. Here we are using air filter. This is a diagram, normal practical industrial image of the industrial air filter. These are used to filter out the contaminants from the air. There are so many contaminants, minute particles, it's provided in the air. This may disturb, or this may have in future it will disturb the system. So it is necessary and it is need to filter the air so that we can remove the contaminants from the air. This is the symbol of this is the diagram of the image of the air compressor. This is generated by using compressed air is generated by using air compressor. Air compressors are either diesel or electrically operated. Based on the requirement of compressed air, suitable capacity compressors may be used. There are so many capacity of compressors available in the market. Then air cooler. During compression, the compression operation, air temperature increases. Therefore, coolers are used to reduce the temperature of the compressor air. Then moisture separator. Cooling air in the cooler results in condensation of vapor in the air. The condensate in the form of water droplets are separated from air. Then the service unit. In the service unit, there are three things available. One is a filter, regulator, and the lubricator. Filter, which separates submicron level contamination. Then the regulator, which brings the pressure of air from receiver pressure to the device pressure. Lubricator, it adds lubricants to the air. Now see the general layout. The pressure switch and control unit, which maintains the pressure in the receiver in the predetermined range by starting and stopping the prime mover. Prime mover means it is a motor. Pipeline, they carry the compressed air from one location to another. Next, control valves. Control valves are used to regulate, control and monitor for control of direction flow, pressure, etc. Then air actuator. Air cylinders and motors are used to obtain the required movements of mechanical elements of pneumatic systems. Then what are the factors to be considered while selecting the components of pneumatic systems? These are the following factors we have to be considered. First one, operating pressure of compressed air, then flow rate of compressed air, then filter rating for selection of filter, then stroke length required for selection of cylinder, then force required and speed required by the actuator, compatibility, durability and cost, port size, pipe size, etc. of are for connections. Then environmental conditions such as the surrounding temperature and the present the location humidity, and surrounding conditions such as chemical and the high temperature, whether it is in a high temperature zone or not. And what about the advantages of pneumatic system? There are so many advantages over the hydraulic system. It is very fast in operation because very low viscosity of compressed air we are using. So it is very fast in the moment is. It can run continuously for a long period. It works better even in hot surrounding. It cools even at 125 degrees Celsius. Sorry, this is 125 degrees Celsius. It better work in mines because it does not generate any spark and hence no chances of explosion and fire hazard. It is very clean and absolutely dust free surrounding. It is environmental friendly. Return line is absent, so it makes the circuit simpler. Leakage of compressed air does not have any problem. If overloaded, system is stalls. System will start working once the load is reduced. This is the main advantage. Then automatic and safety circuits are possible. High effectiveness, high durability and reliability, simple in design, high adaptability to harsh environment, safety, easy selection of speed and pressure, environmental friendly, and it is very economical. Even though there is a disadvantages over hydraulic system, there are some more disadvantages and drawbacks in the pneumatic system. The force developed is very less as compared with hydraulic system. The compression of air is very costly because we are using the compressor. So compressor takes electricity, and the system also it will be compared to the pump. The compressor will be costly. Lubrication is required. System is noisy unless exhaust port are fitted with silencer. Without a silencer, it will produce noisy. Precise control of speed is not possible because low viscosity, relatively low accuracy, low loading, processing required before use, uneven moving speed.
This video will describe how industrial pneumatic systems work. These 5 types of components represent the most common elements used in these systems. The ultimate goal of this entire collection of components, in most cases, is to create motion that will do some type of work in an industrial setting. Pneumatics is one of the most widely used technologies to automate repetitive processes. Some common applications might be to move product from one place to another, or to press or clamp pieces of a product together. To best understand how the system works, we will start at the beginning with the compressor and follow the process through to the end goal of motion. The compressor generates the energy that powers the system in the form of compressed air. In order to generate compressed air, the compressor draws in atmosphere from its surroundings and squeezes it or confines it into a smaller space, creating the energy needed to drive the system. Once compressed, the air needs to be dried and cleaned so that harmful particulates such as rust or dirt does not clog up the moving parts in the system. The compressed air will travel through a tube or line to the next component, called an Air Preparation Unit, or FRL. FRL is short for Filter, Regulator, and Lubricator, which are common pieces that make up the Air Preparation Unit. Typically, the first unit in the air preparation system is what is called a bulk liquid separator, which circulates or spins the air using specially shaped vanes. The rapid circulation of the pressurized air sheds unwanted moisture due to centrifugal force. The next unit is a filter, which further removes particulate and moisture in a two-stage process. Just like in the bulk liquid separator, a series of vanes or louvers in the filter circulates the air in the first stage. In the second stage, the air passes through a screen of sorts, called an element, in order to catch unwanted debris. Once dried and cleaned, it is common to adjust the level of air pressure coming out of the compressor. This adjustment has an impact on how much force the system generates. Higher pressure allows the actuator to put out more force, and lower pressure creates less force. The regulator achieves this using a spring-loaded assembly. The knob on the regulator adjusts the force of the control spring to achieve a desired pressure set point. Whenever the downstream pressure level drops lower than the desired set point, the poppet, or internal valve, opens a pathway for the higher pressure upstream to flow downstream. This continues until the pressure in the system reaches the regulator's set pressure. At this point, the poppet or internal valve closes until there is a new downstream demand. It is also common to have a pressure gauge on a regulator so the user can monitor downstream pressure. Finally, in specific applications, such as air motors or pneumatic tools, a lubricator can be added to distribute a fine mist of lubricant into the compressed air to help lubricate downstream components. Now that the compressed air is clean, dry, and set to the correct pressure for the application, the next step is to direct it where to go to create motion. A directional control valve is used to achieve this task. This directional control valve has a series of internal pathways that can connect the air coming into the inlet port with one of two avenues to leave the valve, called working ports. Depending on the position of the moving element, which is typically called a spool, the air will be blocked from traveling down one pathway and allowed to travel down the other. The high spots on the spool, called lands, will block the air from proceeding down one path, while the lower sections on the spool, called grooves, will allow air to flow around them and proceed to one of the working ports. In this common type of valve, when the unit is not activated, the spool is forced to the left side of the valve by a spring. In this position, you can see that this land blocks air from going out the number 4 working port and instead is forced to go out working port number 2 because the grooved lower section of the spool allows air to flow past it and out to the number 2 working port. In order to change the direction of the air to the number 4 working port, the valve needs to be turned on. In most automated equipment, a PLC or programmable logic controller will instruct the valve to shift using an electrical signal. When the signal arrives at a portion of the valve called a solenoid coil, a magnetic field is created that pulls a cylindrical piece called a plunger towards it. When that plunger is unseated, it allows air from inside the valve, known as pilot pressure, to push the spool to the right. Once the spool reaches the far right side of the valve, the lands or high spots are now closing off the passage to the number 2 working port, and instead directing the compressed air to flow to the number 4 working port. When the signal from the PLC is removed, the force generated by the electromagnet is also removed, at which point the spring on the plunger returns it to its normal state, which removes the air signal that is pushing on the spool. The spring on the opposite end will return the spool to its default position once again, directing air back out the number 2 working port. The PLC can now direct air to whichever port is needed whenever it is needed. The next component in the system, the actuator, will allow us to do some useful work with the air we compressed, cleaned, and redirected. In most applications, the purpose of changing the direction of the compressed air with the valve is to cause motion in different directions. Parker makes a wide variety of actuators, or cylinders as they are also commonly called, that will convert compressed air into motion. The most common type of cylinder is the rodded variety displayed here. The actuator will create motion using the energy of the compressed air that is supplied to it by the directional control valve. we can see that the working port number 4 is connected to the back or cap end of the cylinder. When the compressed air pushes on the piston, it is forced to move forward inside a hollow cylinder that is commonly called the body. The piston is attached to a rod that will extend as a result of the force generated by the compressed air acting on the piston. The actuator will continue to move in that direction until it reaches its physical limit, or if the forced resisting motion, commonly called the load, is higher than the force of the compressed air, in which case the pressure regulator could be adjusted to a higher pressure. Now that we have completed the extension, we will need a method to retract the actuator to its original position. The directional control valve will achieve this by changing the direction the compressed air flows from number 4 working port to the number 2 working port. The number 2 working port is connecting to the head end of the actuator, and when the compressed air pushes on the opposite side of the piston, it will reverse the direction of the piston rod assembly. This reverse motion is typically referred to as retracting. For this actuator to retract, the air that is already filling the cylinder needs to go somewhere, which is commonly referred to as exhausting. The exhaust air is illustrated by the red color and is shown exiting the cylinder and flowing back through the valve, out the muffler, to the atmosphere. This system can repeat this process as often as the PLC tells it to move things from point A to point B in one example. In this example, the PLC is telling the actuator to move this product by sending a signal to the directional control valve, which is using the clean, dry compressed energy to power the actuator. Pneumatics are also commonly used to press two components together in an assembly process to help form a finished good. Through the combination of Parker's air preparation, valve, and actuator products, there's a wide range of applications that can be.
Thank you, students. Thank you for watching this video. Let us see in the next class. Thank you.